until the audio rolls over. Make sure you get for lab jazz. And oh, this thing's not working right. Okay. Made some changes. Let's see if that fixed the audio. Looking at my monitor, it looks fine, so we'll just listen for it. And just so I know that I'm doing stuff, let me. Yeah, it did. Okay. Alrighty here. All right. So, just kind of a quick recap of what happened last week. Um, So we knew that we needed to deploy or get a runner inside the environment so that we could manipulate EKS from inside the cluster. Because our cluster is a private cluster, it doesn't broadcast outside of itself. And so in order to make any sort of changes, we needed a runner that existed inside that operational VPC in one of the subnets that had a route to the AKS cluster and could therefore communicate with it. So we worked on creating the code that would deploy that runner and all that, pretty much got it hammered out. Got um, the whatchamacallit, the uh, permissions and all that set up. The one thing, if you remember, we did have a lot of manual stuff we needed to do after the runner was deployed, as far as like, so basically, we deploy the EC2 instance that is going to be the runner, and we create like a profile for it and set it up so that it has specific permissions by virtue of the IAM roles that are assigned to that specific box. And that's how it has permissions to talk to the cluster. But then you have to go into the cluster, and when you deploy the cluster, apply those roles to the cluster as they call them like access entries. And so we did all that. Um, and then once all that's done, you have a box that has the potential to do what you need to do, but it's still not necessarily talking to GitLab. So then the next step was we followed the instructions for installing the GitLab runner client on the box, and then created the new runner in GitLab, and then using the key that we get from that process in GitLab and the instructions that are in GitLab, we ran all that on the box. And of course, it did reach back and talk to GitLab and started picking up those. Uh, what right now is basically like I'm calling a Helm validate job, even though it's not actually doing that task. It's purely a test job. In fact, let me excuse me, let me go ahead and go into GitLab here, and we will look at what I'm talking about. So I did go ahead and merge that branch because basically the runner was created and it was working. It's still not ideal, but a lot of the work I need to do, I'm kind of doing offline because it's really trial and error, boring stuff. It's not the sort of thing you guys want to watch. But the main thing is this Helm validate script here, which, obviously a lot of it's been cut out. I left it here because I'm going to eventually use this or something like this. Uh, so just kind of like touching on future states. I know I'm going to be having YAML files, and I know I'm going to be having like Helm charts. I'm going to need a way to lint both of those types of files. This doesn't 100% work, but it looks like it's kind of the start of how I will need to do that. So what I basically did is left that there commented out, and eventually what I'll end up doing is creating a couple new jobs that are specifically to lint both Helm charts as well as just standard YAML files. So I haven't bothered figuring out the process to do that yet, but I think this is kind of going to be down that likely in the right direction of what I want to do. But what this does do is that it logs into that EC2 instance that we created, and it does this AWS STS get caller identity. It sets up the kube config. It basically does some really basic AWS CLI stuff and kube control stuff just to validate that the runner does have access to what it's supposed to have access to, and it does, respond. Otherwise, this job error is out, and that's an issue. So anyway, that's kind of where we're at with that. Now, if you recall, and I'm going to go ahead and pop up uh, this guy. We have an architecture here that has a couple things in it that we need to talk about. So for one, we have this network load balancer here. The load balancer is so that we can have a public IP address that when people hit, it gets retranslated to apps inside the operations VPC. Because, like, say for instance, we're running, I don't know. We'll probably eventually run like Security Onion, maybe Wazoo, and some other tools in here. When those are available, we're going to need to be able to expose access to those to things that are outside of us. So that's what the network load balancer is actually supposed to be able to do. Um, and now that I'm thinking about it, I'm kind of rethinking what I was going to do today. Now I'm going to go ahead and I'm going to set this guy up, but I'm going to do this a little bit differently. Anyway, so the problem is, so I'm going to have a few problems here that I'm going to have to work out. For one, I have created this network load balancer. I've got the code already written that creates it. I've been avoiding it because it's broken because there's nothing in here for it to forward to. But I now have that EC2 instance. So just to kind of get this to where it will deploy and work, for right now, I'm going to set it up to forward to that EC2 instance, the runner that we created. That's not the intended use. It's purely just to make the code work and to basically have this network load balancer deployed through code. Eventually, the plan will be to have it actually point towards anything that is deployed inside the cluster. Now, the challenge there is going to be, like, let's say, for instance, let's just say that we have a web server, and our Nginx server that we actually were using for testing is some, I don't know. Actually, while I'm talking about this, let me pop up and make sure my audio still isn't stupid, because that has happened in the past. Sorry, I'm double checking this while I'm thinking about it. Okay, yeah, my audio's still good. All right. So so the problem is that, like, so let's just say that Nginx application is the one that we need to expose externally, and in fact it probably will be one of the original tests that we use once we get to that point. The problem is that all of that is deployed outside of Terraform. So if you remember, Terraform allows you to define those dependency boxes, and those dependency boxes there will pass on information to anything down the line. So, like, the the runner, when it gets created, part of that creation process is it creates these IAM roles that need to be added to the cluster. So when the cluster deploys, it cites the runner as a dependency and then pulls from the output of that runner deployment what that IAM role that was used was, and then that role output gets pushed into the cluster deployment as a dependency and therefore can be referenced. In fact, that's exactly what we do um, right here. Runner role. So we say right here that we're going to declare that runner role as a dependency, and that basically means that once that has been applied, it's going to read it, and the output of that becomes this dependency runner role output ARN. And if we go down here and look right here in the access entries, you can see I have defined a principal ARN of dependency.runnerRole.outputs.ARN. So that way that goes into this module. So when the EKS cluster gets deployed, that includes these two nodes and the cluster service itself, it has an entry that tells it the role being used by this runner here is allowed to do certain things. And that's how that works. Well, the things that are being deployed on this cluster are being done through Helm charts eventually. Right now, we're doing it more as a manual deployment, but either way, no matter what, that's never going to be a Terraform deployment. That's deployed a different way. So we need some other way of telling the load balancer, hey, this application on this IP address, which would be like a 192.168 IP address, uh, is any requests that look like this need to go to that specific IP address. Because that's what a load balancer does is you basically tell it, hey, you're going to get requests for web server at, cowsock.com. And the network load balancer will say, okay, well, the web server could either be 192.168.0.100 or 192.168.1.100. And so I'm just going to split those requests evenly between those two potential web servers. And that's what the network load balancer does. Or you can also use it as, uh, you know, most of us have heard of something called like NAT, and it's usually what you do with a router at the edge of an environment. I have used these AWS network load balancers as purely NAT before, where just like this, I have something that's got an IP address that's a private IP behind, some environment, and I need incoming requests to go to the right place, even though there's no public route to it. I point those requests on a specific IP and port to the network load balancer, and the network load balancer therefore turns that around and sends it to the right private IP address. So either one of those are valid use cases for the load balancer. So, but what that highlights is that, and what I really kind of am rethinking now, is this is not going to be just a Terraform problem. This is going to be, we're probably going to have to define like specific IP addresses that belong to specific applications. And then as part of the deployment process, we're going to have to tell, EKS when it creates the application to expose that application on a given predefined IP address, which I haven't done before. So, uh, and the reason we'd have to do that, so let's just say we're going to do this manually. Like right now, what I would probably do is I'd log into my runner. I would do a get namespace. I think it's describe whatever. I still am not like a rock star in the kube control stuff, but run a kube control command against the cluster that would reply and say, hey, here is the IP address for that application, which would be like 192.168 something. And then I would take that IP address and manually go over the load balancer and say, hey, any requests that come in that look like this IP address, this port, need to be forwarded to 192.168 dot whatever. And that would be absolutely viable. That would almost immediately work. So the problem is I want this to be automated. I want this to be deployed by, Terraform. And I would like as much of the configuration as possible to be Terraform as well. So then that means that we need some way of telling Terraform uh, what IP addresses are going to map where. And I think that is going to require some manual configuration that I hadn't really thought about. Um, and this might be one of the things where I end up doing it manually first, just to see it work, and then come back and set this up. But before I do that, so I talked earlier about how I have that network load balancer already written, which I do. I disabled it by turning it into a text document. Oh, so it's looking for the cluster. So, sorry, I should be narrating what I'm doing here. So these are the inputs for the network load balancer. It basically name and what type it is, tells you what VPC it's going to go in and what subnet it's going to be put in. This will change, by the way, but for right now, that's what it is. Um, and then uh, security groups, it will create the listed security groups here and associate those with the network load balancer. When the security groups basically say uh, 80 through 82 from any IP address are allowed in, um, or no, that's out. So I'm allowed to send southbound HTTP. So I'm allowed to go. Wait, no, that says ingress. Oh, okay. I see what you're saying. Okay. So basically, because it's dynamic, basically anything inbound on ports 80 through 82 TCP are from any IP address are allowed. Any inbound requests from TCP 43 to TCP 45 is HTTPS, so that's allowed through. And really, I think this should probably just be 443 and 80, but I stole these rules from something else, so that they may and probably are not correct. I need to fix that. And then SSH, of course, is 22. TCP, anything on SSH is allowed, which actually, this is one that we may actually want because we might want to SSH to our jump host at some point. So I might, uh, that's actually a valid use case. And then security group egress rules basically says that anything is allowed to go to 192.168.0.0 anything. So basically you're allowed to go to the operations subnet. And then listeners, this is where you set up the actual forwarding. So what it says is like, hey, if you get anything on TCP 43, send it to the CSSO2 HTTPS. Uh, if you get anything on 80, send it to HTTP. If you get anything on 22, send it to SSH. All makes sense. So then what are the target groups? The SO2 HTTPS target group is dependent of the now non-existent security onion output, which this is part of what needs to be changed. I'll have to uh, because when it was originally a EC2 instance, that was something easy to get because EC2 instances are deployed through Terraform and the result is an IP address which can be consumed. So what I'm probably going to do is point it at the runner, and for right now, all these, basically all this will come from the runner instead of the cluster as an output um, or as a dependency. So anyway, SO2 HTTPS was some IP in some zone, and SO2 HTTP was some IP in some zone, and then SSH, same thing, some IP, some availability zone. All this, I think I'm going to go ahead and change to the runner for right now, just to make it work. Um, and Yeah, anyway, so that's really all it takes to deploy a load balancer. So if we update all this, point it at the runner, and basically tell it, hey, when you deploy, the runner is your dependency, and I want you to uh, basically allow these roles to the runner, or these rules to the runner, then we should be able to SSH to the runner, which honestly doesn't have an SSH key anyway. So now that I think about it, that's kind of dumb. But we can set up like a, you know, web interface or run Nginx or something on it, and at least test it. So yeah, that'll be fine. We won't actually be able to log in, but we can test the fact that the runner is accessible. So anyway, that's where we're at. Let's go ahead, and now what I need to do is create this new branch because we're starting on a new thing, and we're going to call this. Okay. Now that's created. Let's go ahead and edit. And I do have a meeting this morning. Let me double check what time that is. I think it's at 10. Yeah, it's at 10. So we got a couple hours. All right. So let's do this. We know it's boundary, network load balancer. First thing we're going to do is rename this. And by the way, this is one of the ways that, like, when I'm working on stuff like this, sometimes I'll create something and then I'll realize I messed up and I need to disable it. I don't like to delete it because a lot of times what I need is there. I don't want to get rid of anything. I just need to disable it temporarily. Well, with Terraform, you can just rename the file from HCL to something else. I use text, and basically it won't be read by Terraform or TerraGrunt. So now that I'm re-enabling it, though, I need to make some changes. For one, the dependency isn't going to be the cluster. The dependency is going to be the runner. So let's do that. And then it's going to be um, dot dot slash operations runner instance. Okay. And then here is we're going to need the IP address and we're going to need the availability zone. Oops, accept. Uh, so we're going to need these two values. So how do we get those? Well, remember, I am a big fan of putting references at the top of my things. So all we do, this is the EC2 instance. I look at outputs. I'm looking for an IP address and availability zone. And guess what? Availability zone is one of the outputs, so we don't have to change that. And I'm looking for IP address. Instance IPv6 private IP. Okay. So if I look up here, uh, oh, wrong one. Going back to the network. Okay. So private IP, availability zone. Basically, the two things I needed are already there, so I don't have to change a thing. So the next thing we need to do is go down anywhere where we had been pointing at the, I think it was what, Security Onion before. Security Onion needs to be changed to runner. So we can do that. I think there's actually like a fast way to do that. Me. There you go. Okay. It's Control F, obviously, for find, and then it's Alt Enter to highlight all of them. So I will change them all to runner at the same time. Boom. Look at that. All done. It was that easy. So let's label an LP, set dep to runner instance. All right. Well, let's go back and look and see if that pushed off. So basically what this is going to do is it's going to deploy this network load balancer and it's going to set all those targets to the runner instead of the cluster for right now. That's just a temporary thing, which I should be able to easily test by, you know, when I go to connect through SSH, there's not going to be a key, so it basically won't let me connect, which is fine. I'll hit it. I'll get there, and it'll refuse the connection, which is good. I could also, in a pinch, like do netcat on port 443 or 80, or I could install like a quick Apache or Nginx server or something like that and throw that up if I wanted to. Tons of ways I could make that work. Uh, but it's none of this is intended to be functional so much as it's just to test the deployment and make sure the network load balancer works. So if this works, I will probably go ahead and merge it and call this piece of it good, uh, because that just re-enables the network load balancer and gets that functioning again. The next step is to get this firewall set up and going. So I'll have to create the inspection subnet. I'll need to deploy the firewall appliance, and that's a whole rigmarole. Luckily, I wrote all of this for another project about a year ago, and I have a copy of all that code. Unfortunately, it was for a government customer, so I won't be able to show the original code. I'll just have to have it up on another screen, and I'll probably reference it and do a little copy pasta. And some of that may actually happen off screen too, so that I don't create any sort of issues by showing off data that I shouldn't be showing off. Okay, so this is running the plan to basically say, hey, if I were going to do that, what would it look like? If this works, I'll turn around and I'll do an apply, and then I'll do a destroy just to make sure that both of those functions work. And if the apply works and the destroy works, then I'll do a merge. I'll reapply and do a merge. And I think, if I remember right, this may be one. When we do the apply, I'll probably put everybody in a standby while I work on that apply, because it just takes a long time. It takes several minutes to stand for the node balancer to stand up. All it is stuff like this, streaming code until it's done. But I'll apply it or I'll stand by it, and that way anyone who is watching this later can just watch for the standby screen to go away and skip all that. Okay, that worked. So let's go ahead and try the apply real quick. So we're going to go to the new branch. We're in development, and if we look, we are in boundary NLB. Subcomponent will be boundary /NLB. And I'm going to copy that because I'm going to need that. And we're going to apply. All right. Well, this will be the first that'll take a little while, so I'm going to go ahead and throw you guys over into standby. I'll come back when it's done, and we'll do a little bit of testing, and then we'll initiate the destroy. Okay, folks. So we are back. Actually, now that I'm thinking about it, let me pop over here and just check and make sure that coming back didn't screw up my audio because, that's happened. All right. Audio sounds good. Okay, so yeah, the job just finished and it was successful. So let's just quick pop out there and look and see if it was successful. So all right, let's see. So I think it's actually under EC2s, but let me check under VPC. Yeah, okay. Here we go. Load balancers. All right, we see CSNLB is there and it's active. It shows all the rules that we expected. Okay, all right. Well, let me see if I have PuTTY installed. All right, so I've got PuTTY here, but first I need to get a um, public IP address for this guy. And now that I think about it, okay, here we go. That's the DNS name of it. I think that's going to be publicly accessible. Actually, here, let's do this. Because typically what you'd do is you'd set up like a public IP address and have that forwarded and everything. We'd set up our networking rules so that they were sending to it, all that stuff that you normally would do. In our case, I don't have that set up. I'm gonna try to skip it all. So okay. So that's the public IP address. Let's go ahead and we're not going to use it. We're going to use our DNS IP address here, or our URL, I guess I should say. DNS name, whatever. All right, SSH. Let's try it now. This is going to fail, but that's okay. What I want is this. This is perfect. So the fact that I'm getting this tells me automatically that I'm successful. I won't be able to log in because, yeah, because it's expecting a key, but that is fine. The fact that I got that at all means that I got to a system that has SSH active. It's just configured so that I have to use a key to log in, and that particular box A doesn't have an SSH key configured, and B, even if it did, I didn't set it one for this session. So this was never going to work as far as logging in. But that prompt, you only get that prompt if you are actively talking to the server. If in fact I can demonstrate that. So let's show a quick demonstration. I'm going to go to uh, instances. Uh, state and stop. Turning that instance off. It is no longer going to be available here any minute now. It's probably good enough. Let's try it again and see what happens. Now to go to the same exact thing. Whoops. Well, let's try that one again. All right. Load balancers. Mapping. Where was it? Oh, it was under details, wasn't it? Yeah. All right. Let's try this again. Now we're going to go again. Look at what I'm not getting. Nothing. Because the server's not accessible. I shut it down. So yeah. So this is what if the port forwarding was not working correctly on the load balancer, this is what would have happened the first time. And it'll sit there until it times out. But let's go back and turn that instance back on. And once it comes up, I'll probably have to go in and actually start the GitLab runner on it because I don't think I have that configured correctly. But that's okay. That's a problem for another time. All right. So that means the apply works. Let's go back and do a destroy. And again, the destroy is going to take time because, of course, it's going to take time to do the planning and build the planning session, and then when that's done, it will stop and wait for me to initiate the destroy, and then that's going to take some time because it's going to take a little while for that to actually tear itself down. Once all that's done, boundary /LP, and once all that's done, I'll come back from standby and we'll go through the merge and then move on because we should have time. We'll move on to trying to get the firewall set up. So anyway, kick that off. Okay, it's running, and I will be back as soon as the all this gets destroyed. welcome back. So we actually had to rerun this because delete protection was turned on, and that prevented the destroy from working. But I went, logged in, and see right here, turned it off. Of course, this guy doesn't exist anymore, but we will check it to make sure, and we can see no load balancers. So that guy's dead. Long live the king. All right. So now what we need to do, excuse me, is go to. Okay, and I did re-enable that runner and that worked, so that's good. All right, so now we need to merge it. So I'm going to create a merge request, and we'll just call it re-enable network load balancer, and we'll call CME. Or whatever it was. Um, okay, there we go. All right, so basically we're going to go ahead and merge this. Not that there's any commits to squash, but what this will do is it enables that network load balancer, and it sets it up so that it basically passes all that traffic through. All the current traffic gets passed through to the rudder, which is fine. I mean, we're kind of using that as a halfway jump host anyway. A good test box. This is the quote unquote development environment, so it's fine to do some weird things. Even if if this were a production system, we would not do this. You would never send the wrong type of traffic to the wrong system. These are the sorts of things you do in dev, so you can figure things out and make your life a little bit easier. But and that's one of those lines that you kind of have to think about a little bit when you work in this environment. You want to make sure that you are never um, that you're never um, crossing those streams. You can do a lot of things for convenience in dev that you should never do in in production, basically. All right, so um, now that that is going, let me pop over here. Okay, and that's done. I'm going to run another pipeline to um, deploy that network load balancer again. Oh yeah, main, because of course it is. Development boundary MLB, because we do want that network load balancer deployed. We basically want, anytime we put something in main, we want to go through and make sure we deploy it so that it's done correctly, but we don't have to monitor it. We can pop back over here and kill that. All right, so now we have our network load balancer. It does forward stuff correctly. And now what we need is this guy. So let's go over here. If we look at our operation, our boundary VPC, we can see our boundary VPC has uh, the default um, route table, which is ignored, but specifically it's got these subnets, the north and southbound. And I don't know why this is showing up as wide. This is definitely dark. Huh. All right. Oh well, I guess that's just the way it is. Anyway, so we have northbound, southbound subnets, which you can see here, northbound, southbound. But we need an inspection subnet. And the reason I didn't create that when I created the VPC is for two reasons. One, when I get ready to deploy the firewall, I want to be able to tell the firewall to deploy into that subnet, which means I need to create the subnet as a separate process from creating the VPC. Otherwise, if you'll notice, in fact, I'll just show you. Let's go to where the VPC gets created, and again, we're gonna use the reference. If we look at outputs, if you scroll down and look at subnets, you're gonna see a public and private subnet. Okay, private subnet arms, private subnet objects, private subnets, uh, private subnet CIDR blocks, private subnet CIDR blocks, and then public subnets, CIDR blocks. Yeah, that's it. Um, so what does that tell you? Basically, what that means is every one of these is a list or a map. Uh, because that's objects, or actually even that's a list. It's a list of objects. Uh, So either way, it's a list. There's a bunch of them, and so there's two ways we could go about it. You could specify which element of the list. So like you could um, go in and say, uh, I don't have a good example here of where I did it, but basically you would say that the dependency is the VPC, and then private subnets is equal to some list, and then your reference, when you reference it as dependency, you would down below you'd say dependency dot boundary VPC dot outputs dot private subnets, and then in like a a box, whatever the brackets, these things. You put like 0, 1, or 2, or whatever to reference which element in that list specifically you're looking for. The problem with that is that they're not always created in the same order as you would expect, and there's just a lot of room for error there. So way better is to, if you were in a situation where you had to do that, I would probably create a custom module where I could set up filters to find the specific thing in the list that I was looking for and return that as an output. And then that would just be one of the Terraform modules that need to be run, and that would be the dependency rather than the other VPC. So instead of getting a list, I get a specific object. And that's kind of where I'm at here. What I'm going to do is I'm going to create the subnet I need to create the firewall. And then instead of having to select one from three subnets, I'm going to refer to that module that created the one subnet I want, and that output will be the subnet I need. So that means that we're going to need to create a new branch. So new branch. And this new branch is going to be add firewall. And we're going to need to edit it. Now I've got about an hour left, so we obviously aren't going to get super far through this, but we'll get it going. So development. So I don't know if I've done this before. I need to create a new like thing, right? So where do I create it? Well, the way I've got this split up is I have applications boundary and operations, network and operations, and really applications is where all the apps will notionally go. Like, right now I've got Nginx in there, but eventually it'll be like Security Onion, uh, Wazoo, whatever else needs to go in there. And then the network are specific network things that need to happen. It's not really necessarily um, like it is. I'm adding the transit gateway. I'm putting the transit gateway in there. I'm adding routes, but it's just the glue that connects these different VPCs. Otherwise, I'm really trying to keep this split between like VPCs. So the thing I'm creating exists inside the boundary VPC. That's where I'm going to create the set. So underneath the boundary, uh, I could call it firewall, but I think I'm going to call it inspection because it's more than just the firewall. It's going to be several things. So I'm going to create an inspection folder, and then under this folder, I'm going to have two other folders. I'm going to have a uh, subnet, and that's where the inspection subnet will come from, and then I will have a firewall. And I'll have to go back and look at my notes of the other code I wrote, but I'm really confident it's going to end up being a lot more than this. Basically, when we create these firewalls, these are under the VPC. So when you create these firewalls, well, really right here it tells you this is all the stuff you're going to need. You're going to have to create like a firewall rule group. That rule group is going to have to become part of a policy. That policy is going to get referred to the firewall, and all of that has to be put inside the subnet. So it's going to end up being a very uh, intensive effort to get this built. But I'm going to start where it's easy, and I'm going to put a README in here because I know I'm going to need one eventually, and that will hold the folder open for me. And and then for the subnet, I'm going to create a terragrunt.ocl. All right. Now, easy mode. I'm just going to grab another terragrunt.ocl and paste it in here, and I'm going to change a whole bunch of stuff. So right off the bat, so here's the thing. I'm in a situation now where I'm creating something that is a little bit different than what I've created before. Get rid of that. Get rid of that. I haven't created separate subnets. All the subnets I've created have been part of, the VPC that was being created, something like that. So uh, this is kind of new. So how do I do this? So what I'm going to do is I'm going to go over here. I'm going to look for Terraform, whoops, module, AWS subnet. Okay. And I am not seeing what I expect to see, so let's look at the VPC module. Subnet, AWS subnet, .private.public. Okay, so I believe that means we're going to have to create a custom module because basically there is no, um, and the way this is referenced, it's just kind of one of those things you get a feel for after a while. But this AWS subnet dot private, um, basically AWS subnet is the resource itself. So this kind of tells me that there's no step between. How do I explain this? So sometimes you'll have a module that references other modules. Like for instance, what I'm trying to think of a good example of one that does this. Um, Actually, the firewall one might. So like there's probably inside the firewall module, it probably references the firewall group module that we were talking about earlier, the firewall policies module, and then under the firewall policies module, it probably references the firewall rule groups module, which that one actually may be a specific resource, but I think that one's a module. And this is you use a policy to create a group of rules and basically make a policy for how those are implemented, and then a policy gets attached to the firewall itself. So what you're going to end up with is a firewall module that references the policies module that references the rules resource. Um, and that's basically because the resource here is directly referenced by the VPC module. I don't think there's, this was a really long way of saying it. I don't think that there's an AWS subnet module. I'm going to go ahead and go back and just relook anyway. Actually, you know what? Is there a browse modules AWS? Yeah, no, it's definitely not there. All right. And I'm not going to scroll through 119,000 dills. So, okay. All right. So what we can do is look for all resources. We know that AWS subnet was the resource we were looking for. And in fact, when we search for it right here, we also are told that it's a resource or it's a data source, and there's no modules listed. So um, let's go ahead and uh, this one exists. So there is a module. I'm kind of leery of using a non AWS provided module though. Yeah, let's not do that. I hesitate because it would be easier, but I don't think it'd be so much easier that it's really worth doing. So, plus, this will give me an opportunity to show you how we would go about creating a custom module and how we handle that. Okay, so here we are. This is what the basic, subnet looks like. This is effectively what we're going to end up doing. It really is going to be this basic. So I'm just going to copy that, and I'm going to go to my IDE here. We are going to be creating a new module. This module, what I try to do is like if it's related to the cluster, like directly, like some of the IAM profiles and stuff was, then I put it there. Otherwise, I try to relate it more broadly. So in this case, I'm going to create a new folder called subnets and subnet, and then I'm going to create a folder under it called create, I think. Let me, yeah, create subnet. Create dubstep. Okay. So by the way, you probably I did it real quick, so I don't think anybody noticed it, but I'm sitting here, even though this is something that only I wrote, but I do the exact same thing when I'm working on code that other people are contributing to. When you're doing something new, look around, see how see what format other people have used, and make sure you maintain that standard as best you can. So like right here, I see I have a transit gateway and then attached VPC. Okay, well attached VPC is specifically what I'm doing, so it's like the verb and the object. And then here I'm adding a route. Okay, uh, I'm gonna follow that same process. And so here, I have subnet. I'm going to create subnet. So I'm kind of following this verb object pattern. And that's why I'm doing it, because I want everything to look more or less the same. And we know we're going to need main.tf, which I'm going to go ahead and post that here. And then I like to do my refs, so let's do a ref. And that way, if there's any question, we know right where to go. All right. And then I also know I'm going to need a variety of those .tf, and I'm going to need an output .tf. Oh, and here's another example, right? I've seen this written as output or outputs. I think outputs is what I've been using, but I'm going to check and make sure. Outputs and variables. Outputs and variables. So, all right. So let's go ahead and get an example of each just so I can preload that file with an example. In fact, I can do better than that because it's variable. I'm definitely going to be using the tags variable. So the route won't have one, but you know what will? The transit gateway will. What? It doesn't. Okay. Well, oh, because it's attached VPC. Yeah, there we go. Definitely want that. All right. Um, so let's start with variables. So we're going to go over here and immediately, actually, you know what? I think it's easier to do it this way. We're going to start with main. And right off the bat, resource best practice is um, when you only have like one resource, you're going to refer to it as this. You will see me not do that in a lot of places because I just kind of learned this recently. But if you only have the one thing in here, it's better to call it this. So VPC ID, that's going to be a variable. So we're going to call it var dot, and I'm just going to actually name it after itself. And same thing down here. And tags equals that. So it's going to be var CIDR block and var tags. All right. So this is all the stuff we need. As well clean it up. Okay. And I'm going to copy this so we can reference it in the variables. All right. So I know I'm going to need my VPC ID. And I'm going to need the CIDR block. Okay, and tags is tags. It's already there, so good. All right. Now, so this one's not going to change. It's a map of strings. That's exactly what we expect. VPC ID and CIDR block, these are definitely going to change. But the question is what type are these? CIDR block is going to be a string. VPC ID is going to be a string, so the type doesn't change at all. But what will change is the description. And the way I like to do this is I go back and look at this, and I will have an argument reference in here that tells me what stuff is. So CIDR block, this says it's optional. It's not in our case. It will be required. So, and then VPC ID. Right here, required the VPC ID. And the reason I do this is because basically I'm kind of doubling down, right? I'm making sure that the stuff that I'm doing here as closely as possible matches the source documentation. Um, for one, it's kind of cheating because I can copy paste the IDs and it saves me a little bit of typing. But really, the main thing is, uh, to the degree possible, I want everything I do to reflect the source. That way, if there's ever any question, people can come over here and look at the source and get exactly what they need. Uh, it's easy to figure out what I did by referencing the source. Now, the other thing I'm going to do is this attribute reference. So all these get output, but I don't really need any of that. What I need is this stuff right here. And these are going to be the things that get created by these. So the way that these Terraform modules work is these resources, when you create them, they have a whole bunch of predefined inputs, which is what the argument reference is. And then it has a bunch of predefined outputs. And the reality is that every input is also an output. You can reference outpost.arn from that object if you want. There's going to be there will be AWS subnet this VPC ID if we wanted to reference that. But typically that's not something that gets referenced. So I just copy paste this because this is going to be the main stuff that we need out. So I'm going to go ahead and create one, two, I don't care about IPv6, so four. So I'm going to have four of these things. All right. And the first one is ID. The ID of the subnet. Second one is going to be the ARN. Anybody else see the typo? Where is the typo? No period. And we copied this. There should be a period there. See? No period. And this is all created in code. So somewhere in code, this period is missing. Um, just kind of one of those weird things. It'll make you a better developer if you start paying attention to minutia like that. Not to call people out on it, but like just to manage on your own. Um, so little things like whether or not the format is correct is going to mess you up. So tags all and a map configuration block. So all these have periods except for the one, which was definitely a mistake. And by the way, that should help you a little bit with your imposter syndrome. The reality is that when something as common, and believe me, this AWS subnet module gets the shit used out of it. So the fact that there's a little typo like that in there, that tells you that whoever submitted this has that many people using their work and they made a really simple mistake like that. So tempering that imposter syndrome a little bit with reality. Okay. So ID, so the next thing we need to do is, here's how we do that. We need to fix these output variables. And we do it like this. So every one of these will be AWS subnet.this.something. So we'll fix that. And then ID is already an ID. This will just be ARN. And tags all. There we go. So this module is created, but you'll notice we don't have a README yet. I'm going to go ahead and create that. And then we'll to do. All right. So now we've got this guy created. Subnet, create subnet. we're going to want to reference it up in our Terragrant up here. So the next thing we need to do is go to modules and add it. So that'll be a C, so it'll go right here. So actually, I'm just going to recreate this one. And call it subnet. All right. Terraform modules. And it'll be subnet slash root subnet. All right. Subnet, create subnet, subnet, create subnet. So now we have a create subnet module that exists. Let's go up here and reference it. So LB module gets replaced. LB module gets replaced. And LB module gets replaced. Clean it up. All right. We're getting there. Excuse me. The other thing we need to do is reference our source material. So let's fix that. All right. So referencing our source material, locals, account vars, module vars, envars, environment, create subnet module, tags, everything we need so far. Terraform module is correct now. And then what are our dependencies? So our dependency for this is definitely going to be the Foundry VPC. So that doesn't need to change, but dot dot slash dot dot slash so it goes two back. Okay, so that should be fine. So yes, dot dot slash dot dot slash. Yeah, okay. So yeah, that's correct. So it goes back twice. Um, and then mock outputs. What do we need for outputs? So what sorts of things do we need from the VPC? Let's look at these variables. So we're going to need VPC ID, CIDR block, and tags. Okay. So really the only output we're going to need is VPC ID because we're going to specify a CIDR block. So let's do that. All right. VPC ID, we don't really need any of the other stuff. We don't need that yet. Okay, and then we can get rid of almost all this stuff. Oops. Interestingly enough, they have a VPC ID already for us. So there's that, right? VPC ID, CIDR block, and tags. Okay. VPC ID, CIDR block, and tags. So, CIDR block, how are we going to set that? We could just type a number in there. I want to check and see if we have specified that anywhere else, though. Okay. So that looks good. All right. So the reason I was checking is because sometimes you might have like a variables file out here or something that you're using to set things like VPC IDs. At some point we may want to do that, but for right now we're gonna do it manually. And so to do that, I actually already have it probably specified right here, 10.00.32.28. So we will just copy that. Okay. All that looks pretty good. I think we're good to go. Let's go ahead and run it, and we're gonna create So that module. Oh, you know what? There's one thing I forgot. We want to name our subnet. Um, so let's look over here. Do we have name as an input? If not, there's another way we can do this. We do not, but we can name it as a tag. Let me show you how to do that. And that works out great because then we don't even have to change our what you call them, module, custom module at all. Oops. No. That works because that needs to be cleaned up too. Okay. Now, what do we name this guy? I think inspection subnet, wasn't it? Yeah. I want to look at the way these other subnets are named just to make sure. Yeah, northbound, southbound. We'll just name it inspection. Okay. All right. That looks good. All right. Let's go ahead and push that. All right. Pipelines. We're seeing it run here. So this is going to take a while because it's going to have to run a whole bunch of stuff. We've got time, so I'm going to go ahead and put it back in standby, and then I'll be back when this is done running. Okay, so we've got a problem. Something failed. Let's find out what it is. All right. Boundary. Okay, so basically we have too many. Yeah, let's look at this. All right. Oh, I'm an idiot. Okay, we don't need that because it's dot slash VPC. We're going back to the boundary VPC, not boundary VPCs. Okay, yeah. I was thinking to myself that felt kind of weird, but that's all it was. So, repo in the dev path. All right, so what I'm going to do is I think everything else is good, so I'm going to let this run. I'll go back and stand by. And assuming that there's no more errors, when this is done, I'm going to go ahead and apply it, and then I'll come back after it applies. Uh, I went ahead and didn't apply, so we've applied the firewall, and it worked this time. And so let's go look at it. Aren't you so excited? I know I'm so excited. Or actually, not the firewall, the subnet. Excuse me. So boundary resource map. Look at that. We now have an inspection subnet, and it is set to use the default route table. There's a few things there that we're going to need to change. One, let's go look at this. Uh, Public IP. Da, da, da. What I want to see is if when I create it, can I specify route tables? I am not seeing that, so I don't think that's the case. That is okay. So what we'll end up doing then is and we're gonna have to do this anyway. So looking at this, what we're gonna end up having to do is set up route tables, and there's a reason why we're looking at this. Northbound has its own public route table, southbound has its own private route table, and then inspection will need to have something that's other than default. But the reason why they each have their own route table is because they have totally different routes. So once all this is plugged in and working, basically the route table for northbound subnet will say anything southbound goes to the inspection subnet, and anything northbound goes to the gateway. And then the southbound will be the opposite. It'll say anything northbound goes to the inspection subnet, anything southbound goes to the transit gateway. And on the inspection subnet, the route table will actually say anything northbound goes to the northbound subnet, anything southbound goes to, or actually it'll say anything northbound goes to the the internet gateway, and anything southbound goes to the transit gateway. And the reason that works is because, like, say you have a packet comes in and it's going to go to let's say our SSH session that we are doing earlier. So the SSH session comes in, it hits the node balancer, and the node balancer says, okay, or the load balancer, I mean, not node balancer. The load balancer says, okay, port 22, that gets forwarded to this runner over here. The route says, okay, if that is forwarded that direction, that means I need to go to the inspection subnet, which it does, and it'll land here. And then in this inspection subnet, it will actually land in the firewall. The firewall will pick it up, process it, make sure that it's fair, and then when it outputs, the route table in the inspection subnet will take effect, and it'll say, okay, I'm southbound. Okay, southbound needs to go to the transit gateway, so it'll turn it around and send it back this way. And that's how it gets through. And then vice versa, when that reply packet comes back, the runner says, okay, here's your data. The route table in operation sends it to the transit gateway. The transit gateway, of course, sends it out here in the southbound subnet. That route says, hey, anything northbound needs to go to the inspection subnet. So it'll basically send it up to the inspection subnet, which again will go through the firewall, get processed, and then sent out to the internet gateway. And that's how we throw the firewall in the middle of this. Now, what does that mean? That means that we're going to have to create the route table for the firewall that sends traffic the appropriate direction, and then we're also going to have to edit the northbound and southbound or public and private route tables, as they're called in AWS right now, to send any traffic through the firewall. And that's how that's going to work. Now, right now we don't have the firewall. All we have is the subnet, which is fine. So the next things that we'll need to do is to create the actual firewall. Like I said earlier, that's going to be a multi-step process. And then we'll need, once the firewall exists and is functional, and our test group is probably going to be just pass everything, just so we can make sure everything works. That's the initial set of rules. And then after that, we'll start looking at um, some open source rule sets that we can load into the firewall and that sort of thing and go from there. But anyway, So for right now, I've got a meeting coming up here in about 15 minutes. We're going to go ahead and call this good. Just to kind of recap where we're at today. We did go ahead and get the runner merged earlier today. We reviewed that and where it's at. And then we went in and added the inspection subnet. I had to create a custom module for it, but that module worked. Oh, the other thing I was going to bring up. So, let me see. I don't know. I think this is going to be it. Yes, update docs. We need to update that markdown. In fact, I need to do it for all of them. So what I'm going to do is I'm going to download over here. And let's open that up. And I'm going to show you how I'm going to do it for just the subnet, but I'm going to actually end up going through and doing this for all of them because some of these have been updated since the last time I did this. So I'm going to click on it, and this is the README for the create subnet. So let's grab that. And then we go over here to the IDE. We go down to our modules, subnet, README, and replace it in there. And so what I'm going to do is I'm actually going to go through after my meeting, and I'm going to do this for every one of the modules because some of them have been changed over the last few weeks that we've been doing this, and I want to make sure they're all up to date. But this exact same process is all I'm going to be doing, and then I'll commit it, and then I'll probably stick there and do another stream whenever I'm ready to start building the in fact, actually, I'll probably do some of the building off stream because some of it's going to be borrowing from old code. But then once I kind of make some headway, I'll do another stream, walk through it all with you again, and then we'll get the actual firewall itself deployed, and then eventually get plugged in. All right. Hey, thanks everybody. If anyone is watching this, I appreciate it, and hope it has been helpful.
Stand with no hands, with a fat sack of that hydro, got me back